we focus on the waste streams that comes from the conventional refineries, lithium refineries. And one of the main impurity that cannot be removed using conventional techniques is sodium. And as you said, sodium and lithium have similar physical and chemical properties. So we add two layers of screening to remove sodium from the lithium stream. First, we have a membrane in our technology that already selects or rejects many other impurities, and it can still have a bit of selectivity between lithium and sodium, but it is not good enough to achieve high purity lithium. So what we do, we also add one more layer, our electrodes that are also very selective to sodium. So from a waste stream that contains a high amount of lithium, we pinpointedly take sodium out.
Hi, Anthony. How are you doing?
I'm good. How are you?
I'm good too. I'm so excited for us to drill into this.
Me too.
All right. So, for our viewers who don't have much of a background about INX, could you just tell us what INX is all about?
Yes. Let me start from the name.
Mhm.
Ionics. It can be separated into three parts: ion, IQ, and S. So we work with ions in water. We add IQ and we build systems. So that's the shortest way to explain our name. And what we do is we try to use our technology to purify high valuable metal containing wastewater. For example, lithium. And we do it by purifying lithium by removing the unnecessary other waste ions. For example, sodium. It's very important for our body, but it is not even suitable for batteries. So if somebody wants to produce lithium ion batteries, then they have to purify lithium to a highest grade so that that can be used. And we try to help achieve this.
That's interesting. And I'll pick up from your USP, which
Mhm.
is how you're able to recover lithium ions even in the presence of sodium. Now,
Mhm.
for those of us who don't know, sodium is roundabout has the same particle size as that of lithium. But
Mhm.
your company is able to still recover at least, if I'm not wrong, 99% of lithium so far in the tests. So if you could just tell us how you're able to do that.
Yes, mainly what we do is we don't focus on the primary streams. We focus on the waste streams that comes from the conventional refineries, lithium refineries. And one of the main impurity that cannot be removed using conventional techniques is sodium. And as you said, sodium and lithium have similar physical and chemical properties. So we add two layers of screening to remove sodium from the lithium stream. First, we have a membrane in our technology that already selects or rejects many other impurities, and it can still have a bit of selectivity between lithium and sodium, but it is not good enough to achieve high purity lithium. So what we do, we also add one more layer, our electrodes that are also very selective to sodium. So from a waste stream that contains a high amount of lithium, we pinpointedly take sodium out. So the entire lithium stream can be reused, and that's how we purify. And this is a bit of a chemistry. So the electrode that we use is a 3D molecule, let's say, and it can capture the ions based on the size and the charge of charge.
Okay, okay, that's interesting. So, when you talk about how you're using wastewater as
Mhm.
your source, I'll backtrack a little bit. Normally, companies they procure or recover lithium ions from brine salts or mines, but
Mhm.
you've used wastewater as your source. So, was there a
Mhm.
particular reason as to why you chose wastewater as a source, or anything that you would probably doing in your research that brought you to this conclusion, like an aha moment that you had that this is what we should focus on?
Yeah, it's a strategic decision actually,
Mhm.
because there are two things happening at the same time. One, in the lab we were we were able to achieve a sodium selective removal, and in the meantime, in the industries, most of the technologies that are currently available, they try to separate lithium by selectively choosing lithium. And whenever these waste streams are generated, they generally disappear in the desert.
Yes.
So there is no mature technology to remove or to reuse these waste streams.
Mhm.
So we have one side, our technology works better to remove sodium, and the other side, we see a problem that can be solved just by removing sodium. So we jump directly into it.
Okay, all right. So, when you were talking about wastewater streams, I know like a lot of industries, food, even petrochemicals, they face an issue when they have to dispose of their wastewater that they're using. The number one industry that comes into my mind at the moment is petrochemical industry. And they are normally looking for a wastewater treatment wherein their water, they could use the water that is being purified, like the recovery water, and they could also probably use a system like a zero liquid discharge system, which could remove the sludge and everything and just bring the water down to crystal forms of sand or mud that could be put into the desert or anywhere. But in your pilot test, have you come across any particular case, a use case, where you were able to achieve a benchmark in the industry that probably no other company has been able to do?
Yes. Firstly, I want to correct one thing. We are still not into the
Yes.
pilot state. We are just before that. We are preparing to build our mini pilot. So we
Okay.
can take the mini pilot to the customers and check in their actual scenario. Secondly, the thing is we use electrochemical technology that also uses membranes. So we are also limited to remove only the charged species in the water, for example, ions.
Mm-hmm.
If we go to petrochemical industries, they also have oil droplets and also other organics.
Okay.
And our system is not suitable for that. Secondly, with our capacity, of course, we can remove ions selectively, and we also want to have highest impact.
Mhm.
And at this moment, to produce 1 ton of lithium, we need at least 2.5 million liters of water. So
Right.
it's a really water intensive process in water scarce areas, for example, in the highlands of South America.
Mm-hmm.
So if we can solve or reuse all this wastewater and improve the yield of the entire refinery by 10% or 20%, will do a very big thing for the environment. So that's why we chose the lithium industry.
Okay, all right. So you talk about electromembranes being used, and
Right.
I think, if I'm not wrong, one of the challenges you may have faced, or if in case you faced, is membrane fouling. Is that something that you faced? And if yes, then how have you tried to resolve this issue?
Yeah, membrane fouling generally happens mainly due to two different tracks. One is organic fouling, another one is inorganic fouling. And we work with refining industries, lithium refining industries. So in the previous steps, they already remove all the organics, even calcium and magnesium. So the waste stream that we treat only contains lithium carbonate and sodium carbonate. And from that, we want to remove sodium. In that specific condition, we don't have problem. But if we go 2 steps before, where we also have calcium and magnesium, then we have to pay attention to scaling. But at this moment, we don't have that.
Okay, so I believe that you could just tell us where exactly can your technology be used, because I was going through the website, and I came across that food and beverage and agriculture, these are the industries where containers could easily, it's like a plug and play system where they can easily be installed. So like number one area where that, yes, this has worked very successfully.
Yeah. At this moment, we would say we are more suitable for any critical raw material. For example, lithium, cobalt, magnesium. Two reasons. One, they are strategically important for many regions in the world. Secondly, they are rare earth elements. So generally, the mining process takes quite intensive in terms of water and energy. And thirdly, it also becomes economically beneficial for both parties with a really true environmental impact. So this is our first target. But as we develop, if we can start to scale up with really low capex, then we will also become more relevant for agricultural industries to remove nitrates.
Yeah, I think you just kind of answered my next question. I was wondering that if you've been able to achieve successfully, you've been able to achieve recovering lithium ion. So if there's any other rare earths element that Ionics can be used to, because this is something that it's going to create a boom in the industry. And if you could if there's anything else, you mentioned cobalt, you mentioned magnesium, and anywhere else that you've seen that, yes, it's able to recover this element very successfully.
Yeah. At this moment, we work intensively with lithium waste streams. We also work with magnesium mines,
Mm-hmm.
and cobalt mines are in our pipeline. But this is what so far we have explored.
Yeah.
But we are also planning to go for example, cesium.
Mhm.
because cesium is one of the byproduct from lithium mines. So many lithium mines in the tailings, they have cesium enriched. So we
Mhm.
also want to see if we can remove cesium selectively. At this moment, we did not validate. We validated our technology only with lithium brines and
Mhm.
some sources, but these are all in our pipeline to explore in the future.
Okay. All right. And Anthony, that I understand that you've now full-fledgedly you're in the role of a CTO, and I'm sure that the change must have been both easy and maybe rough at times. So if you could probably, it's like a personal question that I have. What is that one thing that you've learned over time that has made you go on every day? Like, yes, I'm going to do this. I'm going to work on this every day.
Yes, I have always spent my time in academia
Mhm.
before I jumped into this exacting journey. In academia, what you do, we generally invent maybe 100 different things in 10 years, but we really don't pay attention to see whether it really benefits someone in real life. And at some point, I really wanted to do that. And when I validated this technology, I thought, okay, hey, I can work for example, my initial focus was zero liquid discharge
Right.
in textile industries in India to remove salts, because this is something that I myself experienced when I was in India. And then we found out, okay, hey, we also had to have a business case that benefits both environment and as well as the industries economically, so that we can actually bring technology to the market. Then we found lithium is the right choice at this moment, and we also see how much impact we can really bring to this
Mhm.
industry. So we jumped into it. So every now and then we reflect on ourselves to see how much we achieved in the last 1.5 years. We have moved from an idea phase to close to a mini pilot. So and thinking that maybe in a year or 2 years or 3 years, it's directly going to benefit someone. That feeling is the driving force.
That's very good to hear. I think it's going to motivate me when I go downstairs and start working. But yes, I think it was lovely talking to you, Anthony. And
Yeah.
thank you so much for this connect. I've learned so much about Ionics and beyond what I had read. And it's so good to see that you've grown so much and so fast in just, like you've mentioned, 1.5 years. So all the best for the future.
Yeah. Thank you, Ravina.